Hi guys, today we are going to discuss Indian navigation, Indian regional navigation satellite systems. So most of these guys, we don't know, we will be using the GPS, right? So in our mobiles, we try to know the latitude and longitude values, the navigation, the position where we are, or the position where we have to go with the help of GPS satellites. Actually, the GPS satellites, which were called as GPS Global Positioning Systems, are all about the USA country. So actually, our India are also having the navigation satellites. So our own navigation satellites we have, and very soon in our mobiles we are also going to get our Indian regional navigation satellites. Let us know something about Indian regional navigation satellites. Yeah, coming to the history, so actually we have planned in 1999 when it is all about some because of the Kargil war. At the time, we thought of getting some positioning with the help of GPS satellites, which was Americans. So no, that was not happened with Americans. We have not got the help from the Americans for the navigation purpose. So at that situation, our Indian government approved to go with a navigation satellite which was our own. So that is what IRNS. In May 2013, we started our project, our own navigation satellites. Now we have all about uh, right now currently running total 7 navigation satellites, and very soon we are going to have few more satellites to be in our regional. Actually, the other navigation satellites like American, Europe, and Russian, China, they have the globally navigation, means they are trying to navigate total around the globe. But our India, we are planning for right now only to cover only our Indian region and the borders towards our region. So we are planning in such a way as to our security purpose, and of course, in slowly we'll be going with the commercial purpose. But we have started this for the military purpose most importantly, right? So we have started our IRNSS satellites 1A at the year 2013, which was the date of 1st July 2013. The vehicle name is PSLV XLC22. The orbit which we have launched the satellite is all about geosynchronous orbit, which was the 55 degrees east and 29 degrees inclined orbit. Actually, this is partially failure because of atomic clock. It is still running, but we are not making the operationally purpose. The status is not perfect. The next, we were dealing with the IRNSS 1B, which is launched in 2014 in April 4th. PSLV, the launch vehicle name is PSLV XL C24, which is also geosynchronous orbit. Now, this is an operational satellite. So, like that, we have gone through IRNSS satellites 1C, 1D, 1E, 1F, and also 1G. So, till 1G, all these were launched in 2014 to 2015, 2016. Only in 2016 we have launched 3 different satellites, right? So these are all most of the satellites, all about like 4 satellites we are launched in geosynchronous, and 2 satellites we have launched in geostationary. And all the satellites are operational. Only one, the first satellite, is partially failure. Remaining the 7 satellites, if you can see in recent 2018 IRNSS 11 satellite, 1I satellite, which was PSLV XL C41, which is geosynchronous, which is also an operational satellite. But The first and eighth satellite both are something like eighth satellite is totally failed and the first satellite is partially failed. So you can see here up to 1 to 9 satellites. Out of 1 to 9, the 7 are perfectly running and one is totally failed, the other one is partially running and partially failed. So now you can observe here. So here guys, the one geo 1, 2 and 3, these three black dots which was given in the equator, those are geostationary orbit satellites, and which was given on the 8 mark, like top one 1A and down one 1B 1D and this down one which is 1E. So these satellites are geosynchronous orbit. So all are trying to uh, navigate our Indian region in most of the cases, and apart from the Indian also, we are trying to know the location and navigation about the around the India also, right? So this is about, in short, our IRNSS satellites will be calling it as a NavIC satellite. So this is what the IRNSS 1I brochure. So this 1I brochure, you can see few details about our IRNSS 1I, which was 2018 launch satellite, a recent satellite, which is 43rd flight of PSLV, 28th flight of PSLV XL version, which is a 32 launch of PSLV, which is the first launch pad at Satish Dhawan Space Center. Yeah, which is the target details here, which is all about 284 kilometers of perigee and 20,000 kilometers of the distance where they, which was above the earth, and the inclination 19 degrees and azimuthal is 180 104 degrees. The type, of course, which was the last ninth satellite, which is geosynchronous orbit, and the height from the earth, the our orbit is our earth is always 36,000 kilometers. The inclination is 29 degrees. The longitude value is 50 degrees from the east. Yeah, the same 1I satellite, remaining features few. The lift-off weight is all about 1425 kgs. It is trying to go use the L5 band and S band even. C band for the ranging the payloads. The atomic clock we will be using L5 frequency band. So as I said, L5 frequency band is all about 1.5, 1.11 gigahertz all around. And the overall size you can see here 1.158 meters into 1.5 meters into 1.5 meters. The power 1670 watts. And this is the ninth satellite, as I said, ninth satellite of the Indian regional navigation satellite. Guys, this is the first satellite of the IRNSS, which is also 1425 kgs, and which is tried for the geosynchronous orbit, and the mass it takes 614 kgs, and the dimensions most probably same 1.51 1.58 meters cross 1.5 meters and 1.5 meters. The power it was somewhat less as compared to 1I, 1660 watts, which is lithium battery of 90 amperes per hour capacity, which was 440 newtons liquid motor. And control system, whatever the control systems it has, like um, zero movement system, orientation input form, and of course we should have sun star sensor and gyroscope for reflecting, for getting the solar panels, for the help of solar panels, and reaction wheels, magnetic torque, and 22 thrusters, Newton thrusters as an activator. The mission life will be 10 years. Most of the all navigation satellites, the life will be all about 10 years. So here the IRNSS, the frequency will be L5 band, as I said, 1.1 gigahertz. In more clearly, you can see here 1101.176 gigahertz, or other way I can call 1176.45 megahertz, and S band 2.4 gigahertz, or in other way 2492.02 megahertz. So most probably these regional navigation satellites, even if you go with other countries also, they go with navigation satellite with two different frequencies. One is for military purpose, the other one is for commercial purpose. In the same way, India also. So we have not meant exactly commercially, not in use right now, but very soon we'll be going with. So to overcome some errors from the navigation satellite, actually I have discussed these errors, modulation techniques, and transmission techniques of navigation satellites in previous video. So to overcome all these errors, you should have some base station. uh, our India has GAGAN base station. So this GAGAN base station tries to take the values from the navigation satellites and tries to filter out and gives us the perfect values, perfect latitude and longitude values. So like that, we have multiple base stations. So this is what the GAGAN architecture trying to explain. So there will be some ionospheric shell. So to reach to the flight or some particular station, there could be a chance of errors. So these substations tries to take the values, tries to filter the all errors and gives to uh, the user or some receiver. So this is one type of approach where most probably when comes to the flight, when it tries to land in the airport, surely when it tries to getting down slowly, uh, it is not the way how the pilot can understand with the help of only latitude and longitude values. So that is what most important here. So when the latitude and longitude values, the navigation values are more accurate enough, then only the safe landing can happen. This is one of the most important application for navigation purpose. Mostly the navigation satellites are used. The most critical important application is landing the aeroplanes, right? So here we need accurate, perfect navigation values. So for this, only taking the values from the satellites is not correct. They have to take some sort of base stations. When the flight is all about 400 feet above, they'll be trying to take directly from satellite. But it comes to the 350 feet, less than 400 feet. Yeah, when it is all about less than 400 feet, surely they should take the help of some base station. And with the help of base stations only, it is possible to reach the land very safely. Yeah, like this, we have multiple base stations. You can observe here, we have 7 different base stations for giving the perfect navigation values. Guys, to go with the our own Indian navigation satellites, we have few apps here. ISRO Bhuvan is trying to give our own satellite values. Other than you can go with GNSS viewer app, where it has trying to give you whatever navigation satellites is pointing out your position. This is one of the screenshot where you can see uh, the GNSS viewer app is trying to take all about 22 satellite values. Out of GPS, 8 GPS satellites is projecting, GLONASS, 2 GLONASS satellites, BIDO, 12 BIDO satellites projecting the your position. So accordingly, these are the latitude and longitude values and even the altitude values. Yeah, down you can see what are the different satellites are trying to provide the navigation values, and as well as the ISRO is trying to give you the its own Indian IRNSS navigation values. And a small good news for you is all about for us is all about the Qualcomm is announced that with ISRO the NavIC in our Android mobile smartphones, the NavIC GPS receiver is going to be included, means emerged, such that we can go with the not our GPS navigation, our own Indian IRNSS navigation can be used. So this is what the receivers, guys. This is a GPS, which is an experimental purpose. You can see here, this is GPS antenna. And in this way, this is NavIC antenna, which is IRNSS receiver, right? So this is what the navigation receivers all about. The application purpose, of course, we have multiple applications. One of the most important is military application, and of course, we are using for public safety, surveying purpose, healthcare purpose, agricultural purpose, engineering purpose, and industrial purpose also. So these are the different application areas. As if we are going to get more and more advancements towards the technologies. So in most of the all of the applications, we'll be trying to use the these such navigation uh, satellites. Thank you. If you have any doubts, any suggestions, please keep it in the comment box. Thank you.